Good. Hi, good afternoon, everyone. So, welcome to difference equation class. Okay. So, what was our discussion last meeting was about the uh, two part of closed system. Okay, system can be either open or closed system, right? You remember? And uh, open system means the system that the past action does not control the future action, right? So this is something that we don't really want to. Okay. Now, if you want to develop a real system, then of course you need to develop what is called closed system or feedback system, where the past action will uh, control the future action. Okay. So in here we have positive feedback loop and negative feedback loop, and how you design the system depends on the observer point of view. Okay. Okay, this is the one we discussed last meeting. Okay, so this is a review. So today, I would like to introduce what is called causal loop diagram or CLD. Okay, and this will help you to design the system that you want. Okay, say you have two variables A and B. Okay, and then you check the cause and effect. In this case, if A, then B, then you will draw an arrow like this. If A, then B. So if A, then B. So the pen. Now, if you want to create a feedback loop, then of course, uh, okay, from if A cause or affect B, then in many ways, B is going to affect A circularly, okay, after certain delay. Yeah. So this is called feedback loop. Okay. So that's why we don't know which one first, right? Chicken or egg. Okay. So the CLD is sometimes called influence diagram. Okay, represent the feedback structure of the system. Okay, it will capture the hypothesis about the cause and effect in the dynamical system and the importance of feedback. Okay, so how to develop a causal loop diagram? Okay, these are the steps that I suggest. Okay, number one, you list the component of the system. Okay, what are the component of the system? This is number one. Number two, you decide what is the system boundary. Okay, and then you draw the influence, the direct influence between this component. Yeah, the indirect you don't need to put the arrow. The one that direct influence between the component of the system is the one that you put arrow. This is the one that we, so everything in green, okay, it's easy. You're supposed to be able to do it. Okay. Now what we will do today, okay, is to search for the feedback loop and then label the link polarity and then label the loop polarity. Why? Why we want to develop this? Okay, the first important thing is why. Because once you develop this, you start to create understanding about the system behavior. Okay, you can start to think about the behavior of the system with very simple diagram of CLD. Okay, let us start with this. Okay, so the critical aspect here is you need to think in terms of cause and effect. Okay, it's not it's not correlation, it's causation. So, and then you need to focus on the feedback linkages among this component of the system. Okay, it must be a closed loop. Okay, and then from there you determine the appropriate boundaries, okay, defining what is to be included within your system. Okay, So everything that is outside the system, you don't put inside. Okay, that is not so related, you don't put inside. So as the guideline, okay, again, you focus on the relationship rather than the part. Okay, so remember the structure of the system matters. And second guideline that you need to develop is include in your system policy variables. Okay, within your system, okay, component, you need to add what is called policy variable. And then you will start to see the causation of the pattern. Again, this is the example. Ice cream sales is correlated to the murder rate because it rise in summer and fall in winter. So this is correlation, not causation. Yeah. So if this is causation, then it's become dangerous, right? So here it is correlation. Yeah. When the ice cream sales increase, yeah, then the murder rate is also increased. Yeah? So if this is true, if you put it as that correlation become causation, then the solution, the policy is simple. Yeah? You just cut the ice cream consumption, it will cut the murder rate, right? And save life and allow the society to cut the budget for police and prison, right? But that is not true. Why? Because this is correlation, this is not causation. So in that case, what is the causation? Probably the average temperature. Yeah? So the average temperature increase, it will increase the sales of the ice cream. Okay, so there is another variable called average temperature. When the temperature increase, there is possibility that the murder rate increase because people don't feel convenient. Okay? So again, once you can create that cause and effect arrow, okay, that is not enough. What? You still need to search for the feedback loop. Okay. How do you search for the feedback loop? Use time, meaning the causality is seldom just one way. Yeah? After some delay, it will come back to itself. Okay. So the feedback will cause the ripples, okay, through the chain of causation will ultimately re-affect to itself. So you need to find the karma. Okay. So again, identify the closed causal loop within the system. So think about what is the cause of this and eventually we'll come back to that same component after certain delay. Okay. So I'll give you an example. Say you have salary, performance, tiredness, and sleep. These are the components. Okay. So let us see how we will create this CLD, yeah, causal loop diagram. The more salary that you have, the better your performance, isn't it? So let's say salary versus performance. Okay. The more salary that you have, the higher your performance. Right? So this is positive, isn't it? When your salary increase, your performance also increase. So you put an arrow here. Okay. How about when your performance is increased, will your salary increase? Yeah, over time, yes. Okay. So then your performance increase, it will influence the salary. Right? So then we will say the second example here is tiredness versus sleep. Okay. What happened when you are tired? You need, the more tired you are, the more sleep you need, right? And then the more sleep you need, what happened? The less tired you are. Yeah, the less tired you are. So this is the example of CLD. Yeah. that it will influence, whether it's positive or negative influence, you can still draw the arrow. Okay, so now let's go to the labeling of link polarity. Okay, now you can add the sign, positive or negative sign, on each of the arrowhead, okay, to convey more information. Okay, a positive is used if the cost increase and the effect also increase. So increase, or if the cost decrease, the effect is also decrease. Okay, so the negative sign is used when the cost increase, the effect decrease, yeah, or if the cost decrease, the effect increase. Is it clear? Okay. Now I will put it in arrow diagrams like this. Okay. So you will put positive sign here. When the cost increase, the effect also increase, or the cost decrease, the effect decrease. So basically, direct influence, right? You will put negative sign here. When the cost increase, the effect decrease. When the cost decrease, the effect increase. So this is reverse, no? The inverse influence. So regarding the arrow sign, is it clear or not? Hello, are you still there? Regarding the arrow sign, is it clear or not?
So the erosion, if it's positive effect, then it's up, right?
If the
No,
same
not
effect,
always.
up or
If the
up,
same
down,
effect.
down, then
Oh,
become positive. Okay. If the reverse effect, up, down, or down, up, is negative. Is it clear or not?
okay, clear.
Clear, yeah? Now, let's give example. Again, the same thing, yeah? Like a while ago. If your salary increase, your performance increase, right? So in that case, what you will do, you draw the arrow, and what is the sign?
Plus,
Plus. Very good. Now, if your performance increase, your salary increase, right? So increase, the arrow is
also plus,
also plus, okay? Now, plus multiplied by plus is
plus,
plus, right? So the same thing here. If your tiredness increase, okay, the more tired you are, the more sleep or the less sleep you need. Plus or minus? Jocelyn, the more tired you are, the less sleep. No, the more sleep, right? The more tired you are, the more sleep you need. So this is plus, isn't it? Okay. Now, the more sleep you are, the less tired you are. Is that correct? So in that case, negative. Is it clear or not? Okay, the link polarity, to determine the link polarity, is it clear or not? Give me feedback. You don't show your camera and then you don't talk, so I don't know. You are on mute, Matthew.
Oh, sorry, sir.
If you say something, I cannot hear you. You're muting yourself.
No, sir. It's for the previous question.
Okay. So once you determine the link polarity, okay, you can decide the loop polarity. How? Simply multiply all the arrow sign within one loop. Okay. So of course, when you have plus multiplied by plus, you will get plus. Minus multiplied by minus is plus. Plus multiplied by minus is minus, and minus multiplied by plus is minus. Right? So with this, you start to see the loop polarity that I put here. For example, here, the more bird you have, okay, the more population, right? So that is positive, correct? And then the more population that you have, of course, the more bird also. So positive. Positive multiplied by positive. Now you have positive link polarity. Is it clear or not? Okay. Now the same thing. The more population, okay, of course, the more death, right? This is positive. And the more death will reduce the number of population. So negative, okay? So positive multiplied by negative, now you have negative feedback loop. Up to here, is this clear?
Clear.
Clear, okay. So remember, positive feedback loop is unstable. Negative feedback loop is stable in difference equation or differential equation. You remember that, okay? So now you can combine. Earlier, you only calculate one equation, right? Using this diagram, you can start to see the behavior even if you don't know the equation yet. You see, this is amazing technique. You see? So if you have even number of negative sign, yeah, then you will have positive feedback loop, right? So what is this? It will generate behavior of growth, amplify, okay, deviation, reinforce. Yeah. Well, this is not always, but this is the way to do checking the predicting of behavior just based on the diagram alone. Okay, the value matter later. We talk about the value, but at this time we're just guessing qualitatively about the behavior. Okay, the same here. Remember the salary and performance a while ago. We have positive feedback loop, right? So the more salary I have, okay, I better perform. And the better you perform, the more salary you get, right? And then the more salary you get, the better you perform, and so on. So it becomes positive feedback loop. The arm race that we discussed last meeting, you remember? Country A will in danger, will create the armation of country A. Okay, positive, right? The more armation that country A has, it will generate a threat to country B. Again, this is positive, right? And then it will increase the armation of country B. Okay, again, this is positive. And eventually, that armation will feel threat to the country A again, right? So plus multiplied by plus multiplied by plus multiplied by plus is positive. So we have positive feedback loop. Okay, so then we have this kind of result. Clear? So we can guess the behavior. This diagram here because we know this is positive feedback loop. Any question? Okay. Again, so the same exactly. Yeah. Say you have two system component, our advertising and our market share, right? So what happened? So when we increase our advertising, our market share increase. Okay. But when our market share increase, okay, it will also generate the competitor advertising to increase their market share. So again, all of this will create a positive feedback loop. Yeah, the same behavior like the war. Clear? Now, how about negative feedback loop? Yeah, you will have a number of negative signs. Okay, it tend to be balance, equilibrium, goal seeking. Okay, sometimes you will get fluctuation because of this. Okay, so you put the negative with the loop in the center of the loop. Okay, so this is the example of negative feedback loop, right? The more that you have, okay, the more sleep that you need, right? The more sleep, let's say this positive link polarity. The more sleep that you have, the less tired I am. Okay, so this is negative link polarity. Okay, positive multiplied by negative become negative, right? So the less tired that I am, the less I sleep, and eventually, the less I sleep, the more tired that I am, right? So this will become a fluctuation, okay, with this negative feedback loop, creating a fluctuation. Is this clear? Okay. So how about this one? Is this positive or negative feedback loop?
Negative.
Yes. So positive 3 times and then one negative in one loop. So this one becomes negative feedback loop. So what is the behavior of negative feedback loop? Can you plot?
If there is an odd number of negative
Yes.
loop
So,
in the feedback loop, it will be
yes. So
negative.
what is the behavior? Meaning, what is the chart over time? Okay. So yes, this is a balancing loop, which is negative feedback loop, right? So the
It's
behavior is
going
something
up
like this.
and
Can you see? The behavior will be stable. Okay, the number of students will be stable over time. Yeah, because of the negative feedback loop. Is this clear or not? Okay. So of course, when you have more than one feedback loop within the system, okay, then the value matters. Which one is bigger? The negative feedback loop bigger or the positive feedback loop bigger? Okay. The dominant value in the loop will eventually create the behavior of the overall system. Okay. So, of course, stable condition will exist when the negative feedback loop dominate the loop. Yeah. The positive loop. Okay. So here is example. We have negative feedback loop and positive feedback loop, isn't it? So what will happen to the system? If the positive feedback loop grow bigger than negative feedback loop, the number of population increase, right? So when the negative feedback loop is actually more than the positive feedback loop, then the number of population decrease. Okay. So if this negative feedback loop more than this one, what will happen? The system will collapse. And if you study the, say, anthropology, for example, okay, and history, you can start to see that there are many civilizations that collapse because the number of death is more than the number of birth. And that happened, okay, because of the system in the merit system. For example, there are several case system that certain a group of people can marry another group of people, right? Say you are a blue blood from the king family only. They will only marry certain families. Because of that rule that they impose it in the society, then the whole society will collapse. Can you see that? So you can start to study the system behavior, okay, when you start to have a rule that implement in the society as a whole. So this is how you use differential equation, and CLD is one of the tool that you can use differential equation easily, because now you can see the whole system. Okay, so here again you have positive and negative feedback loop. Okay, the more learning, the more knowledge that you have, isn't it? Okay, the more knowledge that you have, the more you forget. Of course, but the more you forget, the less knowledge that you have. Okay, the more knowledge that you have, it will encourage you to learn more. So now the question is, which one is faster? The forgetting rate or the learning rate? So if you are forgetful, so the policy here is to learn more, right? Is that correct? So that the rate of learning will be faster than the rate of forgetfulness. Okay? Otherwise, over time, your knowledge will decline. Okay. So real world, okay, will have this kind of complex system. Okay, you will have a lot of component, right? And within your component, you will start to create the link polarity and the loop polarity. Okay, so in here, for example, the more sunshine you have, the more evaporation. The more evaporation, the more cloud will be formed, and eventually when you have more cloud, it will block the sunshine. So in itself will create negative feedback loop, right? Here. And then the more sunshine that you have, okay, will increase the temperature of the earth. And then eventually will increase the evaporation. Again, this is positive feedback. Oh, did not even get a feedback loop yet. But when you put this inside, again, this one will have negative feedback loop to the this loop. Nah? Can you see the loop here going here? This is another negative feedback loop. Can you see? And then next is the increase of earth temperature will increase the number of cloud. Okay, so this one is positive, positive, again negative. So this is negative feedback loop. So a lot of loop inside the loop, isn't it? Okay, and from here you can start to draw all the loops that you have within your system. Huh? There are software to help you to generate it. So one of them is FanSim that you can download for free. Yeah, to develop this. And inside that FanSim have a lot of different shell and different equation. So you can use that to model a complex system. Okay, so sometimes you have a system with exogenous item. Look at this. Okay, the sunlight here is an exogenous system that will have an arrow into the system, but there is no arrow go back to the sunlight. Okay, so this is an exogenous system, which is actually outside of the system. Okay, and remember, because we are doing dynamical system, there is always, okay, possibility of delay. Okay, in this example, okay, so this is the planting rate will increase the number of growing tree, positive, right? And the more tree that you have, the higher your harvest rate. Okay. And the higher your harvest rate will reduce the number of growing tree. So in itself, this is a negative feedback loop. Okay. So, but from the growing tree until the harvest, from the harvest until the growing tree again, there are a lot of delay. Right? Okay, now I will give you very interesting case study, okay, from the University of Klagenfurt in Austria. Okay, so my wife was working there before. Okay? So, given the following model, what action do you think we can suggest? Look at the model. This is the model of heroin market. Okay. Okay, let's trace it one by one. Okay. So this is the heroin trade, right? The more heroin trade, of course, the more police activity. So positive here, right? The more police activity, okay, the more heroin secured by the police, right? And then the more heroin secured by the police, what will happen? The less heroin available on the market. Okay, the less mean negative here. Okay, and then now the less heroin in the market, or the more heroin in the market will increase the criminality of the addict. So, and the increased criminality of the addict will also increase the police activity. So on itself, this one become negative feedback loop, right? Okay, and here you will get again a negative feedback loop. And then the more heroin in the market, okay, the more addict who deal with that heroin, okay, and then the more addict, of course, the number of addict also increase, and then heroin trade market also increase. So up to here, it seems okay, right? So what's wrong with this system? What's wrong with this system?
If it results in negative feedback, then making the heroin illegal will increase the rate of heroin.
Look at this. When you have a negative feedback, you will see that the system is stable, isn't it? Right? Then you will say, oh, this system is stable. Okay. And what is the policy variable here? What you can do in here. Which one is the policy variable here? Something that you can act. Police activity, right? Okay. So in this example, the police activity is something that you can do. Your policy, correct? So let us see here. This is the price elasticity of the heroin. Okay. So when the heroin available is, say, for example, 10, okay, the price is 1,000, okay, but because of police activity, okay, so what is the revenue? Okay, 10 kilogram heroin available at 1,000, so say the revenue is 10. Okay, so when because of police activity, what happened? The kilogram heroin reduced, right? Okay, so the number of heroin available in the market reduced. Okay, so the price per kilogram increase. Okay, become 2,000. So 9 kilogram times 2,000, the revenue become 18. So what happened? Remember, the police activity here will secure the heroin. Okay, and then the heroin available in the market reduce. Actually, it will increase the activity of the addict. Why? Because the criminality increased, right? Okay. So you are doing something wrong, okay, because of the price electricity. So what's missing here is actually the heroin price. Okay. So in the CLD, okay, we can see that there is missing component, which is the heroin price. So if you can see, you add this heroin price here, suddenly you will see this is no longer positive a negative feedback loop. This is actually positive feedback loop. So meaning the police activities, right? The police activities will actually have the criminality of the addict. Wow. Can you see that? So look, we discussed all of this just based on CLD, causal loop diagrams. You don't even put any numbers here yet. Amazing, right? So what is the lesson here? Okay, so yes, CLD is very useful tool. Okay, and it can discuss the situation, and of course you need to check more clearly what variable that you need to put inside, and maybe the same situation. Okay, if you missing or too much variable, it can be modeled differently, right? So, but at least using this diagram, okay, you will be sure about what is the model assumption, isn't it? Okay, the clarity of the model is more important. Okay, so and you see the small difference, just one component may have serious consequences in the wrong model. Okay, instead of negative, it's actually positive feedback loop, right? Okay, so what appeared to be the solution at the first part, okay, which is the police activity, is actually make the problem even worse. Right? So what you need to control is not the police activity, but actually the price of the heroin. Right? So that their revenue will be lesser. Okay? Again, this is a qualitative model. Okay? Without quantifying it, it's difficult to see which one is dominant, isn't it? So up to here, is there any question? So now in your uh, group project, can you start to draw CLD? Yeah. In your group project, you're supposed to draw CLD. And then later on, you will draw the SFD, yeah? the one that I will discuss after this. Okay. From there, you develop the system that you want to develop, the dynamical system that you want to develop. So, is there any question so far? Is it clear or not?
I want to ask back
Yeah, go ahead.
about the heroin. Why it's becoming negative? The
Which one?
price?
This one?
Yeah.
The
Why
more
it's becoming
the more heroin available in the market, the less price. The less heroin in the market, the higher the price. So this is a negative, isn't it? Because of the
you
price
got
elasticity.
cut
This one.
you got cut off.
Huh? Because of this price elasticity model, can you see? Because of the price elasticity model, you can see that the less heroin in the market, the revenue is actually increased, right? So in that case, here, okay, when the heroin available in the market decrease, the heroin price increase. When the heroin available in the market increase, the heroin price decrease. So this is demand and supply.
So the previous cycle is wrong in the positive and negative.
Yeah, the previous one
Okay.
is there is look, and the previous one is like this. There is no price, right? So when there is no price, you will think that the policy activities is the one that policy variable, and then you will see that this is a stable system, yeah, because negative, negative, negative. You see that, right? See, this is negative, this is negative, negative. So it's stable system, right? Supposed to be. But why, even though you create the police activity, more police activity, okay, you pay the police to capture the heroin, it's actually increased the criminality of the addict. So what's the missing variable here? The missing variable is the price. So once you include the price, okay, once you include the price here, suddenly you will see, oh, this is not negative feedback loop. This is actually positive feedback loop. You see? Okay. So then the policy variables is not the police activities. The one that you need to secure is the heroin price. Okay. So in fact, you need to reduce the police activity. Right? Yeah. If you reduce the police activity, the heroin price will actually go down. Okay. So any question, any things that you want to discuss with CLD? Tamara, you're very quiet today.
Oh, really?
You got it or not? This one.
Yes.
Okay. Okay. So with this, I hope you can start to develop your own CLD. Okay. For your group project. Okay. So the next one in the Lentera is the system dynamic. Where is the system dynamic? So I think I will share the screen. Yeah. So these are an example in the slide. You can check by yourself. Okay. These are the practices that you can check whether this is positive or negative feedback loop. Okay. For yourself. So let's discuss the system dynamic where you will draw, aside from CLD, you will draw the what is called SFD, a stock flow diagram. Okay. So by the end of this lesson, you should be able to draw a stock flow diagram of the system. Okay. Once you are drawing the stock flow diagram, then you can create the dynamical system, the difference equation inside. Okay, so this is a better approach to create a system, to model a system. Okay, so you can download a free software, for example, Dynamo, Insight Maker, or Fansim. Okay, to draw all of this. If you are using Python, you also can download the pip install the module, yeah, for a system dynamic. Okay, so our focus is the behavior within the system that produce the growth, fluctuation, and change over time. Okay, so all of this called system dynamic, which is basically functional simulation. Okay, remember we discussed earlier about CLD, right? So it's very useful to represent the feedback process and interdependency between the component. Okay. The problem with CLD is qualitative, okay, not quantitative. So you cannot distinguish between the level, okay, the accumulation, and the rate or the flow. Okay, so in this lesson, we will improve the CLD a while ago into what is called SFD, which is called stock flow diagram. Okay, so again, we still use the same thing, okay, a feedback loop. But now, okay, you start to distinguish the state with the rate. Okay, the change is called the rate. The state in here we call it level. So the diagram of level of the state is box like this. Okay, and then the change is basically the decision or action. You will draw as a rate. So this is the symbol. Okay, information at itself is actually a level, so you can draw it like this. Okay, the reason we have dot 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 here is because from level you cannot go directly to another level. Okay. Okay. So this is example of inventory. Okay. What is the rate? The rate is ordering decision, isn't it? How many you order? And then the inventory itself is the inventory level. This is the state of the system. Okay. Based on the state of the system, okay, there is an inventory information that will influence how much you will order. So this in itself is a feedback loop. Okay. So remember, the feedback loop is the basic structural element in the dynamical system. Yeah. So we need to find the feedback loop first, and then you draw the CLD, and then from there you improve into SFD, and then from there you create the equation. Is this something useful? So in the half of semester last time, you are dealing with differential equation, right? Okay. I introduced you also a difference equation. But those difference equation, you are given the different equation and then you find the solution or the stability, isn't it? Now, your task is you need to find that equation. How do you find? Of course, when you want to find the equation, okay, you need to develop what is called CLD and SFD. Is this clear or not? Okay, so this is the tool to create the equation. Okay, so number one, once you have the CLD, okay, you need to separate them. Which one is actually level? Which one is actually rate? The level is the state of the system. We call this stock. The rate is the action. We call this flow. Okay, the rate represents the change, the delta. Okay, for example, in bank balance, the amount of money that you have in the bank is the level, right? The saving that you put in, the withdrawal, that is the rate. Is it clear? So suppose it is a parking lot. Okay. So the number of cars inside that parking lot is called the level, the state of the system. The number of cars going into the parking lot and the number of cars going out of the parking lot, those are the rates. Is it clear? Okay. And this is the nice thing. These two are sufficient to represent the feedback loop, and both of them are necessary. So you only need to separate into two, level and rate. That's it, enough. you can represent any system in the world using this. Did I mention any system? Right? That's including your love, including your hope, yeah, including your belief system. Okay. So here is the diagram, the simplest diagram of quantitative model, which is called stock and flow. Okay. This is the rate going in. Okay. The level is called the stocks. The rate is basically the valve, right? Going in and going out. We'll go to another level here and so on. So here we have two levels. When the system have two levels, this is actually second order system. When you have only one level, this is first order difference equation. Okay, the number of level represent the order of your dynamical system. Okay, these are example, okay, of the systems. Okay, these are the level, and this is the inflow rate, and this is the outflow rate. Okay, so in the bathtub, you have the water in the tub. Of course, the water will enter to the faucet and drain, right? In the bank account, the level will be the balance, okay? And then the inflow will be the deposit, and the outflow will be the withdrawal, yeah? In the department store, okay, the level will be the people inside the store, yeah? And then the people entering and people living in the department store are the inflow rate and outflow rate. Is it clear or not? Okay, so you need to differentiate between level and the rate. Yeah, the rate can be in and out. So let's discuss more detail. Okay, the level or the stock is the state or the condition of the system at any particular time. So the drawing here is the height of the water in the pail is actually the level variable. Okay, so this is the characteristic of level. Look at this. Okay, the present level variable does not depend on the present action, but instead depends on the accumulation or integration of the past action within the system. Okay, so characteristic of level is always accumulation, is always integration. Okay, so for example, your memory, your belief is actually a level, okay, that characterize your mental image. Here is the characteristic of level. The level will continue to exist and can be observed even if there is no present activity. Even if there is no activity, the level still exists. Second characteristic, okay, is that the level will provide the basis for the action. The level fully describe the condition of the system. Okay, rate variable is not needed to describe the system. You only need the level. Okay, say for example, oh, that person is rich. When we say that person is rich or that person is clever, okay, when we say that person is rich or clever, what we are referring to? We are not referring to the rate, isn't it? Yeah, the rate means the income or the spending, isn't it? We are leveling to the level. Okay, when that person is rich, we are talking about the level of wealth that they have. Okay, when we said, oh, that person is smart, maybe the level of knowledge that they have. So it's a level, accumulation. Okay. Next, here is important. Level can only be changed by rate. Level cannot change other level. The same thing, rate can be only changed by level. Okay, so the level or the stock variable is computed by the change due to the rate variable, okay, that alter the previous value of the level. So level cannot directly dependent on other level. So in here, for example, the level here influence the information. Okay, this is just copy. This is not action. There is no possibility that direct influence. So in here, that's why we call it dash line here, because this is just a copy. Yeah, any interdependency between two levels must arise because there is connecting flow rate. There must be a flow rate here. Is this clear? So level is the source of the delay. Level characteristics number 5. Level is the source of the delay. Any delay will involve level. The same thing, information is level. Now, information is level, so we call it apparent level, okay, which may be different from the true level. Okay, so information is the basis of the current decision process, right? So this is the characteristic of information. Information is not determined by the current condition, the true condition, but is actually based on the past condition. Okay, there is a delay between the true value and the actual information. Okay, so when there is a discrepancy between the true value and the information, that is always exists in principle. What happened is, in practice, we put that the level, the true level and the information, sometimes we put them together, okay, as no distinction. So this is to simplify the situation. Okay. Now, the next part is action or the rate. What is rate? Rate is decision that produce action. Okay. Remember, rate will alter the level. What is the characteristic of rate? The rate will cease, will be no more, okay, when the action stops. So when you don't have any activities, then there is no rate. There is no change. Okay, when there is no decision, there is no action, there is no change. Okay, so when we say change, always caused by the decision, okay, by the action. So this is the characteristic of rate. Okay, the present rate of flow does not determine the present value of the level, but it only tells the rapidity or how fast, how slow the level is changing. So rate is basically the slope, okay, the change per unit time of the level variable. Second characteristic, remember the rate does not depend on its own past value or depend on the time interval between the computation. Okay, rate is the action, is the decision, so it's not depends on that time. The third characteristic of rate is that no rate of flow can be measured except as the average over period of time. So in this case, in principle, no rate can control another rate. Remember, rate will affect level. Level will affect rate. Level cannot affect level. Rate cannot affect rate. Is this clear? Okay. Now, you may ask, how do I know this is rate or level? Right? So imagine if all the activities in the system is brought to rest, okay, no activities, no action, no decision. What is remain in the system? The one that remain in the system that you can observe, those are the level variables. Okay, example here. A tree, okay, can stop growing, okay, but the accumulation of the height will be still visible, isn't it? Say on holiday, say several weeks ago, there is Idul Fitri, right? The factory activity stopped, so no sales, no employees, yeah, okay. So, but the number of employees working in progress, the capital equipment, the bank balance, okay, that's including the reputation, okay, the employees' morale, okay, the quality of the product will still remain, isn't it? Even though this is holiday, so no activities, okay? So the one that remain is called the level. Is it clear? You can distinguish between rate and level. Okay, rate is change. Yeah? Level is actually the state of the system. Okay, with that, we have what is called decision. So decision process in here, okay, is not human decision. It's broader than just human decision. It can be decision of a machine. Okay, so decision process is just one that control the system action. Okay, it can be human decision, but it can be also the decision mean the action of the valve, for example, in the chemical plant. Okay, the natural consequence of the physical structure. Okay, probably subconscious decision and the biological system. These are also decision. Okay, so then you will see that every decision is made within the feedback loop. Okay, and the decision is always based on information, so that the decision will control the action and will produce the level. Okay, the level will produce the information, and then again it will create the decision. So it's a feedback loop. Okay, and any decision process can be part of more than one feedback loop. So remember, decision represented by the rate of flow. Okay, last part here is the policy. Okay, so policy recognize the local goal toward which the decision points strive, comparing that to the goal. Okay, you compare the goal with the current system condition, and then when you compare, you see the discrepancy, right? This is what you want, and this is what is the current situation. See, the goal is something that you want, and then you compare with the current condition, then you will have what is called discrepancy. Okay, based on that discrepancy, you create action. Okay, that action is called policy. So we have what is called rate equation here. Okay, with that introduction, okay, very long introduction, you have what is called goal, right? And then you have what is called observed condition, current condition. And then what you will do, you get the discrepancy between the goal and the current condition. Okay, from their discrepancy, you produce action. Okay, I will give you example in a minute. Okay, so here, say you have a target level. This is your goal, right? And you observe the current level. Remember, this is current level, yeah, not the rate. And you check the discrepancy. Okay, from there you create the action, yeah, the policy, the flow rate, the decision. This is an example. What is your desired inventory? This is the goal. What is the current level of inventory, right? So when you minus this, you get the discrepancy, correct? And then you put the factor here, just that one, and then you will get the action, which is the order rate. Okay, this is how you create the system. So you create the action, which is the rate. Then you ask, how about the level? The level is given. because the level is always accumulation, so it's very easy. Yeah. So what you design is the rate. Okay. So once you have the rate, the flow here, then you will have a diagram called stock flow diagram. This is, what is this? This is the CLD. Yeah? Okay. This is the CLD. Now you start to put them, okay, from the CLD, I will distinguish which one is the flow, which one is the stock. Okay. The flow is the rate, the stock is the level. Okay. So then you will draw this kind of diagram. Okay, so this is the symbol. This is like the common symbol. So the level will be put in the box. The rate will be put as the valve. Okay, and then you can add some auxiliary variable. And there is a source or sinks cloud like this. And this is the constant. Sometimes we use a diamond like this. Okay, and the flow just an arrow. Okay, that's it. Okay, this is the level. Okay, level is basically the state which you accumulate or you integrate the rates, right? And then the rate or the flow is basically the decision, the action, okay? And then the auxiliary is just a formula, any formula that you can include in your system, okay? And the source and the sink represent something that outside the system, the boundary of the system, okay? So the source is the something that go in, okay? The sink mean the flow will go out to the sink. Yeah, something like this earlier. Yeah, this is the source. Here is the sink. Can you see that? Okay, with that, we can start to develop the differential equation or different equation, okay, using this diagram. So suppose you have a constant flow with a linear level with no feedback, okay? So R here is the rate, L is the level, okay? So initially the level is 0, and this is the difference equation, and the rate is constant. Then this is the chart that you will create. This is the simplest stock flow diagram. Say, how about here? In this example, this is the CLD, okay? I have the rate and the level. Rate is the R, the level is the L here. See, we have a positive feedback loop here. Okay, so then you draw the SFD. The SFD is just the box and the valve. Okay, so going from the level going to the, and from the rate going to the level. So here is the arrow. From the level going back to the rate, here is the arrow, right? And once you draw this, okay, inside the software will generate automatically the differential or difference equation. Yeah. Here, this is the, what is this? This is the rate, right? And this is the level. Okay. And of course, you just put the value here, then you will get the curve. The same thing with the next example. Yeah, this is the equation. The next equation is the population and the birth. Again, the same birth rate and population. This is positive feedback loop, right? So the curve is like this. Okay. How do you get that? Yeah. All you need to do is you put the birth rate, okay, design the rate equation, say for example 0.02 times the population here. Then this is generic, yeah. That initial value is 100, then of course dt times the birth rate because you connect this one. Okay. The level equation is always given. So once you connect, it will generate the equation on itself. Okay. So again, I give you example here is SFD with negative feedback loop. Okay, so we have negative here and positive here. So this is a negative feedback loop, and the curve is stabilized. Okay, so the equation is you design this rate equation. Okay, so dl dt is equal to minus k1 times r, example. Okay, so the r is k times L2. So these are the one that you design. Okay, and from there, you, for example, you put k1 times k2. Okay, if you combine together, right? Then the level equation is always given. Yeah, always accumulation. So up to here, is there any question? Yeah. Maybe you need to.
Sir, I think you are on mute.
So we have sorry, we have practice here. Okay, we will do a first order positive, first order negative, and second order negative. You can do it in Excel. Okay, after that you can do it in other programming language if you want. Okay, first we will grow the model of Salesforce. Okay, so I will give you the model. You need to solve the simulation in Excel. And then you need to plot the variable versus time. Okay, here is the model. Okay, so, ow. Okay, so the new salesmen are. Okay, sorry. So you can read by yourself. Okay. The new salesmen are located and trained by existing salesmen. Okay, the larger sales force, the more men there are to train the new salesman. So we have the rate equation here. So this is the salesman hiring rate in men per week. Okay, S here is the number of salesmen. What is this? This is the stock. Okay, and this is the flow. Okay, so S here is the number of salesmen. Initially, you have 6 salesmen, and STT is the doubling time. For example, every 50 weeks, you increase, okay, to be double. So you can use time period of 20 weeks. Okay, and now the question is, can you find the number of salesmen over time until 300 weeks? Okay, so here it is. you will, because the time is increased by 20 up to 300. Okay, initially you have 6. Okay, initially you have 6 here. Okay, and then from this 6, okay, you calculate the HR, which is the salesman hiring rate, right? Which is S divided by SDT. Yeah? SDT is given, which is 50, right? S initially have 6, so you put there here. Okay, so initially you have 6, right? And then you calculate the SSR, okay? And then from there you multiply. 6 multiplied by this, you will get this change in the salesman. Okay, so eventually, okay, you will get this value at the end. Okay, try to do it in spreadsheet. Okay, so the plot should be like this.
Hi, sir.
Yes,
Are you okay, sir?
I don't know, I get so much pain, so I don't know.
Sir, do you want to stop the class?
No, it's okay.
Do you want to stop now? It's
No,
okay if
it's
we
okay.
stop now.
It's okay. No, it's okay. You can continue. You can practice first. I want to see your progress.
Yeah.
Mhm. Maybe I should put this in the lentera. I'm not sure if I already put this in lentera. Practice. No, I will add one. Practice. And Okay. Can you see in Lentera, I put practice dynamical system here.
Yes, I can see it.
Okay, so I hope you can practice this. Okay, to keep you understanding. Okay, so this is what you need to do in first practice. Okay, okay, I'll just explain and then you practice. Okay, so this is how you update the formula. Okay, so the change in salesman is just time period multiplied by the sales hiring rate, right? And then the salesman, okay, at time t plus dt is just the salesman times t plus the change in salesman, right? So what is this? This is just the first order difference equation, isn't it? Okay, so the level equation is always this, yeah, first order difference equation, very simple, right? And then after that, you will see the salesman hiring rate is the one that we define, yeah, here. Okay, HSR is S divided by SDT. So this is the one that you decide. Okay, so in this example, we are giving this design already. Okay, with this, you can start to so if I use a Power Sim, okay, the software, I will get exactly the same result. Yeah, or you can use FanSim, or you can use Excel. Yeah, so you don't need to use. Yes, Kenneth, you want to say something?
Yes, I want to ask about the change in salesman. How do we get that?
The change
Sorry.
in salesman, the change salesman is just time period, which is 20, right?
Okay.
Times the HSR.
Yeah.
Okay, the HSR is here. Salesman hiring rate. This one. This one is salesman hiring rate.
And the okay. And
Okay.
the SHR is the
This one
salesman
is
divided
hiring
by.
rate. This one is salesman hiring rate. This one. Can you see?
Okay.
Okay. So this is just the same as this one. Which is the same as the salesman. This is the level, yeah, divided by a constant, right? What is the sales doubling time? 50, right? Correct? Okay, so with this, and again, I'm telling you the level equation is always given like this, so it will not change. Okay, the one that you change is actually this one, yeah, the order rate or the rate equation is the one that you decide. Okay, now I give you the second one. Yeah, this is negative feedback loop. Again, first order. Okay, we model inventory of warehouse. Okay, okay. Here, because this is negative feedback loop, right? What you will have? You will have the desired inventory. This is the goal, remember? And then you have the inventory. This is the current system. When you put negative value here, what you will have, this is the discrepancy a while ago. Okay, the one that I talked a while ago. Yeah. So from there, you create the order rate. Yeah, the action is the order rate. This is the action, the decision. Again, you use time period of 2 weeks. Yeah, plot until 24 weeks. Okay, the same things. Now you will see the plot is like this, stabilized because this is negative feedback loop. Okay, so these are the values, and the updating formula is this one. Okay, so you can again you will look. Okay, the inventory, which is the okay, the level. Okay, IT plus DT and then IT. Yeah, this is the first order equation, right? Okay, the level equation is always like this. Okay, so what you design is actually this one. Can you see the rate equation is the one that you design? Is this clear? Yeah. So now, yeah, this is in the software. So then you draw the CLD, FFD. Okay. Okay. The last one is this one. Second order now. Remember, each order represent one level. Yeah? If you have second order, mean you have two levels. Okay. So second order system will have two level variable. Okay, will become oscillation. Okay, let's do this simplified inventory model with additional delay. Okay, again, I will give you the model you need to solve using Excel. Yeah, here is the model. What is this? This is negative feedback loop, right? So this is the positive feedback loop. Yeah. So RR mean the receiving rate. Okay. GO mean the good of on order. You can start with 10,000. And then DO is the delay of ordering, right? So there is a delay between ordering of the good and the receiving them into the inventory, right? So now, because this is two level, you have each level, you will have its own rate. So you have two model of the rate, okay? And now you plot all of that, okay? Say up to 100 weeks, yeah? Again, you put into spreadsheet, something like this, okay? And when you plot, you will plot all of that. So you will see, even though they are fluctuate, it will stabilize on itself, yeah? Over time. This is the behavior of the system. And this is the updating formula. Again, I'm telling you, okay, uh, the one that accumulate like this is the level equation, yeah? This is also the level equation, right? This is the change in the level. So the one that you design is actually the rate equation. Okay, so the message is rather simple. Okay, okay, try this and then you practice the three of practice here. And if you have any question, I will be here to guide you. Okay, okay, go. And this is another example. Anyway, so that three first. If you can do the three practices here, I think you are good. With this, you can create any system that you want. To start with the first one, probably the easiest. This one. Because some of you are not here, so I will give assignment. Okay, exactly the same. So
Sir,
yes.
if you want, we can just do homework, sir.
Yes.
Later, we can consider WhatsApp.
Okay, no problem. I'll put here homework up to 1 week is okay.
Yes.
Okay. Okay. So this is the homework. Okay. The answer is already there anyway, so you just need to do it just to force you to practice. Yeah. And if you have any question, you can send a text to me in WhatsApp. No problem. You can answer.
Okay, sir.
Yeah. So thank you very much for today. Thank you for attending.
Thank you, sir.
Thank you,
Thank you,
sir.
sir.
Bye bye.
That was soon.
Yeah.